Good day, everyone. Welcome to our physics class. My name is Elsie Bindanyo from BSED Science 2. Before anything else, let's have our learning objectives. The students must be able to first define the generator, second describe AC and DC generator, third one is how generators work. Our topic for today is the generator. So let us define what is generator. A generator is a device that converts motive power of fuel-based power into electric power for use in external circuit. It is a machine by which mechanical energy is changed into electrical energy. And there are two different categories of generator. The first one is AC generator. It is also called alternators. These are one of the most necessary device as it is offer electrical power in various conditions of life. The second one is DC generators are mostly found in off-grid applications. And this type of generator is designed by Simply. This generator mainly converts the mechanical power into DC electrical power by a process called electromagnetic induction by Michael Faraday. So let us illustrate the figure 1, AC and DC generator. So this is how it works. I want to tell you how it works. So if you have magnetic field in the red and you have a coil on wire, by spinning that wire on the magnetic field, you are changing the magnetic flux through that hoop. And so because you're changing the magnetic flux, that in the hoop will be induced an EMF, and if it is connected to a complete circuit, a current in the wire, so that you are doing is you're taking mechanical energy and turning off the hoop, and you're turning into electrical energy. So let us detail how does it work. Okay, so here is a side view of the hoop. So like this, if this is the hoop in the field of fading, that way in this is one is going to look like that. And so if it is straight, or whereas the hoop is rotating then, and it's rotating about this axis, it is rotating like this. So how does it work, the hoop, and then it is rotates like that. So that hoop is rotating around like this seats, like such. Now is it's got the most flux through it this way, and then it's only get a part of that flux. This is the way on how there's no flux, because you see how there's nothing through this window. All this field is wave. So but you're turning it with a constant angular speed, and so the omega, that W omega, and that's to show that the speed at which you're turning it. So before we go to any further, let's just talk about the flux. Then on the flux, the field is going to be uniform, and the flux is just gonna be this. And then the magnetic field B is going to be the dot B, B dot A, and now it's just B is changing now because B is always uniform in my setup. It is A changing now in the area. The hope is not changing. It is always the same in area. So what is changing is the orientation that the hope makes with the field. And so that's how you're changing your flux. And I want you to see this. In this case, the A will be this way. A will be this way. That the A vector is the same direction in B, but it is the one that A vector in this way. So A is this way, that is A vector, and so here it's what's called the dot product that says the part B, and you need to only take is the product says takes a part B, that that in the direction of A, and you can do this is either take the part of that it's in direction of B. But if it's the theta, yes, the theta is the angle, then theta is only not the part of B. So to get the component of B, that is the cosine of theta. Yes, the cosine of theta, that's going to be cosine of theta of the times A, that gives me the same thing. So remember that this is a scalar quantity, so the what you're going to take from this is sheet here, as that the magnetic field is I'm going to getting to say is just going to be times magnetic field B times A, and the cosine of theta, so that if you are in this case of EMFs, this induced hope is going to be an equal of negative. So it's going to be induced EMF that going to equal negative n, depending on how the hopes, how we have times, and how the fast flux is changing with time. So dp, the db to ba cosine, yes, ba cosine of theta. And now something about theta. Theta is related on the average angular speed of delta. So theta over delta t. Yes, it is the average of delta over theta t. And theta, next is we can make it that the final t, final f, the final t, the initial. But what if t initial is 0 and the t initial is 0? So I'm going to make this 0 to get rid from the theta. So the final over time is final, and if we bring the time of final in other side, the theta is going just to be equal of the omega. So omega t, if you want to know that we're going to take in the rotation, just multiply and times the omega. Okay, so my flux is going to be equal b times a times, and so next is theta work. So okay, we're going to here is just over here, and it is the EMF derivative by magnetic flux BA cosine with the okay, so it's negative, just like that, negative n sine okay, so that's the EMF induced, and I'm going to write just it in on sheet of paper. So let's see how we can make sense of this and coming over here. So again, I'm going EMF induced then is negative n, the derivative b, and with respect of time. So okay, it will turns out that the b and the a is changing with the time, so I can bring them outside the derivative. And so when I take this derivative, then the cosine of omega t is with the chain of the rule, and I'm going to get this going this, it's going to be negative a, negative n ba. Okay, so that's the unknown, the omega times the sine of omega t, and that's going to be a positive now because it's the derivative of the cosine. Yes, and it's just like the EMF induced, and I'm going to write just its own sheet of paper and let's see how can make it sense of its coming over here. So let's the EMF that's induced by spanning each bunch of coils were through a magnetic field. The EMF that induced is going to be unequal, just writing it all, and I'm actually write it a different. So it's gonna be WN B sine omega t. Okay, sine omega t. The reason that I wrote different because WNB is sounds like that a Women's National Basketball Association. It's just nice way to remember it, right? So I want to just make a little sense if this is of this. So how do I get when I'm turning the generator, a handle generator, let's say? So how do I get the biggest EMF possible? Well, there is a few ways that I can up the amount of EMF. One is I can, well, there is a do the one is I can turn it faster. Remember that you can turn it really faster if the light bulb for a generator with a light. So the light bulb that the generator was connected, it would light even brighter, or I could add number. So turns to, so I increase the turns from like say one of or two terms of 100 of the magnetic field. No, it turns that the boost of the EMF as well as, or I could make the magnetic field that it was spinning in, I could make the bigger, or I could make area of the hoop bigger, I could make the actual area of the hoop bigger, and so those different ways, and I can changing the EMF. But If I've noticed, if I were have a plot of EMF versus time, so it's a sine wave, so it's just going to be gone something like this. Maximum is gonna be W sine theta, WNBA, that will be a maximum, and the minimum will be negative WNBA sine theta. And that's if I'm turning with a constant omega, so you're not generating constant power. But there are ways to make it a little bit more constant than this, but now you would be making, if you hook up, and you'd be making alternating voltage, and it is connecting to alternating current. So I think that's all I want to share. I hope you learned something. May God bless us all.